Hi guys, today we are going to learn about solving linear systems by graphing. So this is the first time that you've seen the word linear systems, and what that means is two or more linear equations. So we are going to figure out, we've been solving one linear equation and we've been solving for x or for y or whatever the variable is. Now we're going to solve two equations and figure out what their solution is together. So go ahead and title your paper, Solve Linear Systems by Graphing, and go ahead and write down our first definition. A system of linear equations, or we call them a linear system. This consists of two or more linear equations in the same variables, meaning we are only going to be seeing x and y variables for the next few days, so those are the variables we are going to be using. So go ahead and jot down example. In the middle here we have example 1 is x plus 2y equals 7, or equation 1 is x plus 2y equals 7, and equation 2 is 3x minus 2y equals 5. So if we're thinking what would be a solution for a system, we know the solution for one equation are all of the points that fall on that line when we graph it. Okay, if we're talking about our lines here, every point is a solution. But what about two lines? What would their solution be? And their solution is actually one ordered pair, in some cases, that satisfy both equations, meaning it's their point of intersection. It's where these two graphs intersect. Okay, and there's going to be special cases where things go a little crazy, but for right now we're just talking about the point of intersection. And we've done this before back in our functions unit where we were finding where two graphs intersect, and we came up with equations from like Taylor's CDs and Byers Warehouse, I believe it was, where we were finding when they cost the same for the same number of CDs. That's essentially what we're doing, except now we're looking at a little more algebraically. Okay. So we're going to do about 3 examples. So here's the first one. So go ahead and draw your graph and write down these two equations. So to solve the linear system, that means we need to graph both equations and we need to figure out where they intersect. So if we look at equation 1 is already written in y equals mx plus b, or y equals the rate of change times x minus or plus the y-intercept. So we can go ahead and start graphing this. Remember, my y-intercept here is this -7. So when I graph, I'm going to go down 1, 2, 3, 4, 5, 6, 7 and place my dot. And then my slope, if you look at the number in front of the x, is really 1. And remember, we can write your slope as 1 over 1. So that means my directions are up 1 and to the right 1 from my y-intercept. So up and to the right, up and to the right. And my smartboard's a little off, sorry. Up and to the right, up and to the right, and this ends up being my line. So at this point, I'm going to go ahead and draw my line through the points. Okay, so, and you might want to use a ruler for this or make a whole bunch of lines, or points rather. So equation 2, well, if we look at this, is this in slope-intercept form? No, it's not, so we have to manipulate it, okay, just like what we did at the very beginning of this unit. So to manipulate it, remember, I'm solving for y. I need to get y by itself, so I need to subtract x on both sides. So I have 4y is equal to a negative x, or negative 1x minus 8. Then I have to divide every term by 4. So I end up with y equals a negative 1/4 x minus 8 divided by 4, which is 2. So I'm going to come over here and I'm going to go ahead and graph. My y-intercept is this -2, so I'm going to go down 2. And my slope is a negative 1/4, which means I'm going down 1 and to the right 4. So if I go down 1 and to the right, 1, 2, 3, 4, oh my goodness, looky there, 1, 2, 3, 4, it already shows exactly where it intersects, where they cross. Okay, and so their point of intersection is right here where the blue and the red intersect, which is right here. I'll make it green. And the ordered pair is our solution. So the ordered pair is 1, 2, 3, 4. So 4, comma, down 1, 2, 3. So 4, comma, -3 is my solution. So we can check those answers, okay, 4, comma, -3, by plugging in the 4 for x in my equation and the -3 for y in the equation to show that both are the same. So remember, that was proving a solution to your system, and we did this back in the functions unit. So that's a way to check your work. See how everything comes full circle? Crazy. All right, here's on to example 2. So go ahead and make your graph. Go ahead and write down your equations. We're going to go ahead and get started. So equation 1, we have to manipulate it. So let's go ahead and do that. I need to subtract 3x because I'm solving for y. I have 2y is equal to negative 3x plus 10. And then I need to divide everything by 2. And so my equation is y equals a negative 3 halves x plus 5. So I'm going to go over here, go up 1, 2, 3, 4, 5. And then my slope is down 1, 2, 3 over 2, down 1, 2, 3 over 2, down 1, 2, 3 over 2, and I could keep going and connect my line, and your lines need to be straight. It's hard to draw straight lines on the smartboard, sorry. All right, so there's line 1. Line 2, almost in slope-intercept form. I just need to divide everything by 2. Y equals a negative 3 halves x plus 1. So I'm going to come over here and I'm going to go up 1. And then my slope is down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. What do you notice? If I go up 1, 2, 3 over 2 to kind of reverse it, what's happening here? Well, hopefully you're seeing that these lines are actually parallel lines. Parallel lines. I hope I spelled that right for you. So, parallel lines, in this case, do those lines ever intersect? And the answer is no. They never touch one another. They will never intersect. So how are we going to figure out what the solution is? Well, this is one of our special cases. If they're parallel lines, if you notice in the equation, don't they have the same slope? Both slopes is this negative 3 over 2. So parallel lines which have the same slope. So if they have the same slope, that means that they are parallel lines, which means they never intersect. So that means we have no solution. All right. So this is one of our special cases. Please make sure you have that all written down and make those connections. Parallel lines mean that they never intersect, so there's no solution, and we can tell that they're parallel because they have the same slope. That's going to be important now and later on in the unit. Last example. So go ahead and copy down example 3 and the graph, please. So if we go ahead and look over here, well, equation 1, once again, I need to subtract x on both sides. Negative 2y equals negative 1x minus 4. Divide by negative 2 to everything, and I get y equals negative, it's really a 1, right? So negative 1 divided by negative 2 is a positive 1/2 times x. Negative 4 divided by a negative 2 gives us a positive 2. So I'm going to come over here and go ahead and graph. So up 2, and then my slope tells me to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. All right, and go ahead and I couldn't go down and to the left, right, because I'm going in 2 negative directions, which turn into a positive. So I have this. Second equation here is going to be y equals 1/2 x plus 2. Well, isn't that weird? Doesn't that kind of look like that one? All right, well, let's see what happens. So again, my y-intercept's on the same point. I'm going to go up 1 and over 2. So it looks like these points are identical. So the lines are identical. So what does that mean? Remember our solution, we have the same line here. That's our issue. And a solution is where they intersect. Well, aren't they always intersecting? Yes, because they're the same line. We graphed one line on top of the other. So if they're the same line, meaning they have the same slope and the same y-intercept, that means we have infinitely many solutions, because they are always intersecting. All right, so go ahead and make sure you have all 3 of these in your notebook. And here is the summary, okay? So summary, we have one solution when the lines intersect. Remember, they have to have different slopes in order to intersect, okay? For no solution, the lines are parallel, and that means that the lines have the same slope and different y-intercepts. They have to have the same slope in order for them to be parallel because they're moving at the same rate, but they started at different points. So they're never going to touch. All right, and then infinitely many solutions, the lines coincide, meaning that they are the same line, they have the same slope and the same y-intercept, they are identical. So we have 3 different options here just like we did when we were solving equations, except now we're solving systems, 2 of them. So here's your exit slip. Go ahead and make sure you have that done for class the following day. Thanks.